what we're looking at here is quadratic relations. A quadratic relation is when you graph a quadratic relation, what shape does it form? What did your graphs look like? Yeah, a U shape, okay? It's a U shape. And what did you notice about the U shape? All of these graphs were actually symmetrical, right? You can put a line, symmetrical. You can draw a line down the middle and cut it in half, and both sides will be identical, right? So let's look at the first one. The equation was y equals x squared for the first one. Okay, this is always referred to as like the parent function. So everything that you graphed afterwards, we're comparing it to this graph, y equals x squared. Okay, what did you notice about this graph? Where did it start? Where was the center of the graph, basically? At the origin, okay? This is referred to, we're going to talk about this later, as the vertex. Okay, we'll talk about that a little later on. I'm just kind of giving you an intro right now. But the graph, the center of the graph was located at 0, 0 at the origin, right? And how did this graph open? Okay, so this graph opened up. Okay, so let's look at the next graph. Here we have an equation. Okay, this one's graphed in green. Again, I have the parent function in white. Okay, everything we're comparing is to y equals x squared. I just left that there. And then the green graph is y equals negative x squared. What did you notice happened when there was a negative in front of the x squared? How did the graph open? Down. Okay? The white graph opened up, and now when we put a negative in front of the equation, it opened down. Is it the exact same shape as the other one? Yeah, when you were working on the table, the only difference was that the values were negative. The y values were negative, right? Everything else was the same. Once again, we're comparing the equation to the white graph, to the parent function. So this time we have y equals 5x squared. What did you notice that happened to the graph? It became narrower. Good. Narrower. We can use the word skinnier. And you're going to see a lot in your textbook that this parabola, this graph, became stretched. So think of an elastic band. If you take an elastic band and you stretch it, it becomes thinner, right? So what did you notice was in front of the x squared this time? What number is this? Okay, we put a number that is greater than 1. Anytime you have a number in front of the x squared that's greater than 1, you're going to discover this. The parabola becomes stretched. This time, we had an equation of y equals x squared, but then we added 2. What happened to the graph? Where is the vertex of this graph? It started at, the center of the graph is at plus 2, right? Positive 2. This graph actually shifted up from the origin 2 spaces. Did the shape change? No. Was there a coefficient in front of x squared that was greater than 1 or less than 1? No. So the shape of the graph did not change. It just shifted up. Y equals negative x squared plus 5. What did this negative tell us? That it opens down. And what did this plus 5 tell us? The vertex. So it, instead of starting at the origin, it started at positive 5. That was where the center of the graph was. And it opened down because there was a negative sign in front of x squared. Did it stretch? Did the shape change? No, because there was just a 1 in front of x squared. Okay, the last equation you looked at was y equals 0.5 x squared. What is the coefficient of x squared here? 0.5, right? Is it positive or negative? The graph opened up, but this time what happened to the shape of the graph? How did the shape change? Yes, it became wider. Okay? What was the value of the coefficient of x squared? It was a decimal number. Anytime that value is a number between 0 and 1, so a decimal or a fraction, it's going to make the graph wider. And the word that you're going to see in your textbook is, I want you guys to copy this down, compress. You're going to see this word a lot. You're going to see that the graph can either be stretched or compressed. So once again, think of an elastic band. If I take this elastic band and I push it down, I'm compressing it. What's happening to it? It's becoming wider. These were the 6 equations that we just looked at. What was the degree of each equation? Yes, they all had a degree of 2. Okay? All of these had an x squared term in it. When you guys calculated the second differences in the table, what did you notice about all the second differences? They were all the same. Were the first differences the same? No. If the first differences were the same, it would have to be linear. You learned that in grade 9. We can see that if the second differences are the same, it's going to be quadratic. Every single time, all of these were quadratic, which means they formed a parabola, a U-shaped curve, a symmetrical shape. All of these equations were written in, this is called standard form of a quadratic relation, okay? We're going to talk about how A, okay, this is the coefficient of x squared, right? How that value, that number, affected the graph. So if you recall, when A was a number that was greater than 1, what happened to the graph? Copy this down, this is important. When A is a number greater than 1, the graph is stretched. When A was a value that was between 0 and 1, so like a fraction or decimal, anyone remember the word that I taught you? Compressed, good. If you want to put in brackets, this one is skinnier, and this one is wider. Okay? Again, we're always comparing this stretch or compression to the parent function, to the original y equals x squared. If A is a positive number, so if the number in front of x squared was a positive value, how did the graph open? Think of the letter U in the word up, okay? Up, right? When A was a negative number, so when we had a negative sign in front of the x squared, how did the parabola open? Down. So they looked like this. When we had a plus or minus a number, when we had a constant term added or subtracted to the parabola, to the graph, what happened? What happened to the graph? Here we had plus 5. What happened to the graph? Yep. The parabola shifted up, and where is this point located? What's the coordinate of this point? 0, 5. What is this referred to as on a graph? The y-intercept, right? Here we had plus 2, so we know that the y-intercept is 2. That c value represents the y-intercept of the graph when it's written in this form, okay? When it's written in standard form. So when all your second differences were positive, how did the graph open? Yes. If all the second differences were positive, the graph will open up. That will tell you how the graph's going to open. And if they're all negative, it will open down. Okay, so the second differences actually relates to the a value, the coefficient of x squared. If it opens up, a is positive. Remember we just talked about that? And if it opens down, a is negative. So if I give you the equation y equals negative x squared, you know that this is going to open down, and my a value is negative 1, right? Okay? But What's the standard form of a quadratic relation? I just wrote it on the other page. Y equals ax squared plus bx plus c. When you graph the quadratic relation, the graph, all those graphs that you just looked at were called parabola, okay? So anytime you hear me say the word parabola, I'm referring to the graph of a quadratic relation. The parabola, so the graph, has something that goes through the vertex. Anyone know what this is called? We can imagine a line of symmetry, okay? Because any parabola will always be symmetrical, so you can imagine that there's a line of symmetry that cuts it in half. It has to go through the vertex. This is the middle point of the parabola. Okay, if the first differences were the same, it would be linear, right? So which differences have to be the same? Good, the second differences are the same, and they can't be 0. If they were 0, it would mean that the first differences were the same, which means it's linear, right? If a is greater than 0, which means that's positive, how does a parabola open? If a is less than 0, which means it's going to be negative, the parabola opens up and down. Good.
Made with Doodlecast Pro.